Hi, this video is the third video for Lecture 5. In this video, we will show how interest rates and coupon rates affect the valuation of bond. In previous exercise, we showed that if the interest rate or the discount rate is high, then the market price of bond will be low. In the opposite direction, if the interest rate or the discount rate is low, then the market price of the bond will be high. So we summarize these situations in these three lines. In the first line, we can think about the example with the yield rate as 10% and the coupon rate as 8% in the second video for this lecture. So in this example, given the yield rate as 10% and the coupon rate as 8%, the market price of the bond is $924. It is lower than the face value $1,000. So in this case, we say that the bond is in a discount price. That is to say, the market price of the bond is lower than the face value of the bond. In the first exercise of the second video in Lecture 5, we discussed the yield rate as 8%, the coupon rate as 8%. So the yield rate is equivalent to the coupon rate. In that case, the market price of the bond is $1,000. It is equivalent to the face value of the bond. So in that case, we say the bond is in par price. So the market price of the bond is equivalent to the face value of the bond. In the second case of the exercise in the second video for Lecture 5, we show that if the yield rate is 6% and the coupon rate as 8%, then the market price of the bond is higher than $1,000. So in this case, we say the bond has a premium price. That is to say, the market price of the bond is higher than the face value of the bond. So, given that if we change the interest rate, the market price of the bond will fluctuate, then we have this concern of interest rate risk. In fact, how interest rate will affect the valuation of bond depends on the maturity of the bond. Here is a graph for bond with coupon rate 9%. And here we consider the face value of this bond as $1,000. Now I want to provide details for the diamond curve. The diamond curve has grade in diamond shape. It describes the market price of the bond given different levels of yield rate. So in this diamond curve, if the yield rate is 9%, given the coupon rate as 9%, the face value as $1,000, and the maturity as 10 years, then the market price of this bond will be $1,000 because the yield rate is equivalent to its coupon rate. Now, if the yield rate is lower than the coupon rate, say 3%, then we can see that the market price of this 10-year bond is around $1,500. It is higher than $1,000, the face value of the bond. What occurs if we change the yield rate to 13%? So now the yield rate is higher than the coupon rate 9%. We see that this 10-year bond will have market price at around $800. It is lower than the face value of this 10-year bond. Now let's compare the diamond curve with this rectangular curve. So this rectangular curve has each grade in rectangular shape. It describes the market price for this 1-year maturity bond. Again, this bond has a coupon rate as 9%. So we can see that when the yield rate is equivalent to the coupon rate, the face value, the market price of this bond 1-year bond is equivalent to its face value $1,000. If we have this yield rate at 3% lower than the coupon rate, then the market price for this 1-year bond will be at around $1,050. It is slightly higher than the face value of this bond. If the yield rate is 13%, that is higher than the coupon rate 9%, then the market price of this 1-year bond will be at around $980. It is slightly lower than the face value of this 1-year bond. So in short words, if the maturity of a bond is long, then the interest rate will have a larger effect over the market price of the bond. In previous slides, we calculate the present value of the bond, assuming that you will hold the bond until the maturity date. What if we don't hold the bond until the maturity date? For example, for a 30-year bond, so the bond will mature after 30 years. Now, what if you hold the bond for 25 years? So you will sell the bond after holding the bond for 25 years. We want to calculate the market price for this bond investment. First, we need to find the market price of the bond with 5-year maturity. That is the selling price after in the year 25. So in the year 25, we find the selling price as the 5-year maturity bond. And then we calculate the present value of the selling price with this 25 years discounting factor. And then we calculate the present value of the coupon payment for the next 25 years. And then we combine these two parts together to calculate the current price or the present value of this bond investment. In the opposite direction, if we know the market price for holding period 25 years, we know the selling price of selling the bond 25 years later, and we know the coupon payment, the holding period of this bond investment, then we can use this equation to back out the required discount rate. We have a terminology for this required discount rate. We say it is holding period return. So holding period return is different with yield to maturity. In calculating holding period return, we use the market price of holding the bond with shorter periods than the maturity length. In calculating yield to maturity, we calculate the required discount rate, assuming you hold the bond until the maturity date. What if we are holding a bond with no coupon payment? So for this kind of zero coupon bonds, the bond issuer pays zero coupon payment and pays the face value at the maturity date of the bond. Typical zero coupon bond can be the short-term treasury bill. Now let's consider an example. If we are holding a 5-year zero coupon bond, given the discount rate at 6%, what would be the market price for this 5-year zero coupon bond? We can calculate the present value as the face value of this bond divided by 1 plus discount rate to the power of this maturity as 5 years.